All right, so I think I'm recording here. Let's take a look at these problems. We have, in each case, they give us two functions, f and g, and they want us to determine if these functions are inverses of each other. So what we're going to do is find the function composition, and if both function compositions equal x, then we'll claim that they are inverses of each other. If not, we'll say that they're not. So in number 5, we want to find f composed with g of x. So we want to input g into f, and g is the function 2x minus 5. Now f always creates a subtraction problem where it's 5 times the input minus 2. Our input is 2x minus 5. So we distribute the 5. And I get 10x minus 27. So since this is not equal to x, I know that f and g are not inverses. I'm going to do the g composed with f just in case somebody had started with it. But I'm expecting this to not be equal to x. So this time the input for g is f, and f is 5x minus 2. So what does g do to this input? G always creates a subtraction problem where it's 2 times the input, no matter what that input is, and then minus 5. So we distribute the 2, and we get 10x minus 9. But since that's not equal to x, we can say that these are not inverses of each other. All right, so let's move on and do this. I guess it's D. All right, so it's repetitive. We're just going to do the same thing again. Let's find f composed with g. Where we're taking g of x as the input for f. G is this ratio 1 minus x divided by 2. F always creates a subtraction problem where the first term is always 1 and the second term is minus 2 times the input. And here, the input is this ratio. So if we, the 2's here cancel, and we have 1 minus 1 plus x, and this does equal x. So it's very likely that these are going to be inverses. We do have to check the other composition to make sure. So this time f is the input for g. F is this 1 minus 2x. G always creates a ratio. The denominator is always 2, and the numerator is always 1 minus the input, and in this case the input is 1 minus 2x. So in the numerator we have 1 minus 1 plus 2x divided by 2, and you can see how this is going to reduce to x. The 1 minus 1 cancels, and 2x divided by 2. The 2 divided by 2 is 1, so we just have x. So these functions are inverses of each other. So you could rename G F inverse, or you could rename F G inverse. It doesn't really matter. Let's take a look at this third one here. So again, let's start out finding F composed with G. That means that we are having G be the input for F. And G is this ratio 1 over x minus 3. So F always takes the input no matter what it is, and the first term it takes the reciprocal of that input. And so 1 over this, the reciprocal of 1 over x minus 3 is x minus 3. Here, I'll do it in steps though. If you take 1 over x minus 3 plus 3. So this first term is just saying take the reciprocal and we get x minus 3, and the minus 3 and plus 3 cancel each other out. So it looks like it's likely that these are inverses of each other. So now we find the other composition where f is the input of this function g, and f is 1 over x plus 3, and g is this ratio that has 1 over the input, which is 1 over x plus 3 minus 3. So let's look at that denominator. We have 1 over, well, the 3 minus 3, they cancel. We have 1 over x. So again, it's saying take the reciprocal of 1 over x, which is just x. So since these are both equal to each other, they're both equal to x, we conclude that these functions are inverses of each other. All right, so hey, I hope that helps. Ask me any questions as needed, and I'll talk to you later. Bye.